Welcome to Cloud Coffee and Certs, the podcast where we chat about cloud certifications, learning cloud skills, and staying confident on the tech journey. Grab your coffee, relax, and let's level up together.
Hey everyone, welcome to another episode. In this week's episode, we will be covering a few more exciting topics around AWS networking. We have covered so far AWS VPC basics, Route 53, transit gateways, stick load balancers. I think they pretty much cover the crux of AWS networking. But of course, because we are building something more advanced, we are preparing for a specialty level of examination. So we are expected to know more than just the basics of networking. And in line with that, in this week's episode, we will be covering another few components around AWS networking. One of them is Cloudfront. Before going into details of Cloudfront, I will be discussing about baseline architecture design, which actually cover different aspects of cloud networking on AWS. So of course, more exciting topics are covered in this episode as well. And as usual, I will be discussing about one of the news item as well. And that will be this time around APIs and how different level of exposures around API testing can actually cause risk in your cloud infrastructure. So like I said, more exciting topics and amazing content in this episode. And after this short break, let's begin our journey.
Let's hit pause on everything else for a moment and look at what's changing in the world of cloud and security lately.
Now, as part of news, today we are diving into a cybersecurity topic that's becoming increasingly urgent as more organizations spin up their own AI systems. And it comes down to a pretty simple problem. So, if you recall in the last week episode, I covered a simple problem around infrastructure which we create for testing. And in this week's episode, the simple problem is the doors which we leave open into our AI infrastructure. Now, AI is something which is still new, which is still in build phase. I know more and more organization, they talk about in their sales pitch, they talk about like AI based infrastructure, AI based solution which they are selling. But doesn't mean that everyone is building that infrastructure as securely as one should expect. As per a recent piece, again from the Hacker News, they make a compelling argument. The biggest security risk in LLM deployments isn't the AI model itself, it's everything around it. Because ultimately, your AI models, your solution, which is creating these LLMs and working on these models, it's working on some infrastructure, of course. And one of the component is APIs. We of course have dashboards, service connection, and everything basically which we call as endpoints. And every new one of that adds another potential door for an attacker. Now here's the thing. These exposures rarely happen from one big mistake. It's more like you have multiple thousand minor faults or minor doors, which of course when you leave them open, they cause like sort of, if I say, death by something like 1,000 cuts. So if a developer opens up an API for quick testing and forgets to add maybe authentication, or if a hard-coded token is never rotated, someone may be building a throwaway debug endpoint and never takes it down. It's sort of something which we already cover around the infrastructure which we build for testing, and then we never remove it. So this sounds familiar, right? And these kind of like small, easy decisions, which otherwise one should be fixing pretty normally as part of their day-to-day routine, but if we leave them open, they make kind of a final deadline into quietly making maybe a massive vulnerabilities, to be honest. And what makes this more interesting is these LLM environments are designed to build to connect the things. I mean, you are not supposed to build your AI solution and just keep it running inside without connecting to outside, or maybe without connecting to different components within your organization as well. For example, if you call databases, or if you are talking to cloud services, if you are putting some sort of automation workflow, if whenever a single endpoint is compromised, it's just not this model, it's potentially traversing into your entire infrastructure. And this is something which this articles call force multiplier. And that's actually a great way to put it, because you are actually multiplying your problem, and wondering you can go anywhere. And there's a whole category of risk around that, which this article called known human identities. For example, the API keys, service accounts that let AI model to do their different things automatically. And teams often give these broad level of permission to avoid friction, or maybe they forget to close them down, or maybe they themselves don't know what level of permissions are required, so they just try to avoid rework of making what I call like limited permission by continuously testing what exact service account permission you are required for a particular application to run. Sometimes we just give the broad level of permission to make sure that it's up and running in shorter duration. And over time, you end up with a sort of like overprivileged, long-lived credential that nobody is keeping track of. So this article recommendation is around one core philosophy where you assume attackers will get in, so limit the damage when they do. So practically speaking, that means applying zero trust principles. Every access request gets verified every time. And it means least privilege access for both humans and machines. It means just in time permission. So elevated access only exists when it's actively needed. And it also means that rotating your credential automatically rather than hoping that nobody noticed when a token is leaked. So I think bottom line is, if you are building or running your AI infrastructure, security conversation can just be about the model. It has to include every endpoint, every credential, and every implicit, I should say, trust relationship you have built around your infrastructure. Because if you're running something with automation without human oversight, a single exposed endpoint can actually cause like a big problem inside your whole infrastructure. So that's the key. I mean, if you want to make sure your whole infrastructure is secure, make sure you are not leaving any endpoint open, or you're not leaving the service accounts credentials without rotation, you're not giving them over privileges. And these minor fixes can actually make your whole environment, your whole infrastructure more secure. So this time it's around how the exposed endpoints can cause more risk into your AI infrastructure, into any infrastructure, to be honest. I mean, even if you're not into AI world, if you're building a cloud-based infrastructure, still it's causing a same level of risk. So this is about the news which I wanted to cover, because I found it really interesting, because this is something which is linked to again our networking part, because AWS networking is making sure that you are connecting different components within the cloud securely, and you are not just peering everything with open access. So once you are inside your infrastructure, you can easily just move around into different components without anyone noticing it. So we have to put different controls around it, and that's what we are covering as part of AWS Advanced Security Certification. Now, after this short ad break, let's move into our main episode with today's content.
Let's level up, refill coffees, and dive into the main episode.
All right, welcome back. So now we are starting our main syllabus topics from this week. And one of the first subtopic of domain one is designing a solution that incorporates edge network services to optimize user performance and traffic management of global architectures. Now, as part of this, we should be having knowledge of AWS services like Cloudfront, AWS Global Accelerators, API gateways, because different subtopics actually revolves around all these components. For example, one of the subtopic is designing patterns of for the usage of content distribution network, which is CDN provided by AWS Cloudfront. We have to design patterns for global traffic management, which should be using AWS Global Accelerator. And we have to make sure that we have integration patterns for content distribution networks and global traffic management with other services, which covers Elastic Load Balancing and Amazon API Gateway. Now, some of the components, as you can understand from this subtopics list, is already covered, like Elastic Load Balancing. But of course, CloudFront, Global Accelerator, and Amazon API Gateway is something we should be covering as part of our advanced discussion. Now, let's start with AWS services like CloudFront, which they mention as part of like a core content distribution network we should be using as part of our AWS infrastructure. Before we dive into that, I will put link in the show notes about a white paper which actually discuss all the AWS overview networking services. And this is very interesting because they actually cover everything from edge to core use case, and which particular component should be fitting at what stage. So if you check that link and you can find out a nice diagram of cloud networking from AWS. And that actually provide all the basic services. So the first service, which is networking foundation, covers AWS VPC, transit gateways, and AWS private link. We have covered two of them, and private link, of course, I'll be covering whenever it is related to any of the subtopic. Post foundation, we have global and hybrid connectivity, which covers AWS Direct Connect, Cloud WAN, and site to site VPN. We still have to cover these three components as well. So again, they will be covered whenever we have chance to discuss them around any of the subtopic. Then we have solution around edge networking and content delivery. Amazon Cloudfront, which we will be discussing today. If time permits, we will also cover AWS Global Accelerator. AWS Route 53, already covered it as part of our basic introduction. And then AWS Data Transfer Terminal. In terms of application networking, we have Elastic Load Balancer and Amazon VPC Lattice. We have already covered ELB as part of our basics, and of course, we'll be discussing more advanced use cases whenever we have subtopic around it. And last but not least, we have network security and remote access that actually cover our network firewall solution, Cloud VPN, and AWS verified access. Now, as part of details of each subcomponents, this white paper cover everything. So you can actually go through around reading this. So for example, if I go to CloudFront, it gives a basic detail of CloudFront as well. So it covers most of the basics of each solution and of course each service. You can check that out. It's an interesting white paper, and what I like about it, it is showing different components where they should be fitting. So it's not like we are supposed to use CloudFront anywhere. We should be using CloudFront only when we have the scenario of edge networking and content delivery. We don't want CloudFront as part of our basic solutioning requirement. So that's the white paper which I wanted to bring up. And of course, you guys can check that out. Now let's talk about CloudFront. What is CloudFront? Well, at its core, CloudFront is AWS Content Delivery Network, or CDN. So it's as simple as that. And if you're not familiar with CDNs, I think the simple example is if I have a web server sitting in a data center in maybe US East 1, and a user is in maybe, I don't know, Asia and some country in Asia, and they are trying to load my website. Now, without a CDN, that request is going all the way across the world and from whichever country in Asia to this US East 1 server. And of course, that causes a lot of latency despite of having big pipelines and cables on the seaside. Doesn't mean that we have like unlimited fast access to everyone. So CloudFront fixes this by caching our content at the edge locations around the globe. So instead of going all the way to US East 1, maybe the user in Asia gets served from nearest AWS edge location, probably one in their country itself. So every country or every location on the edge, AWS have created these edge locations, and they are fast, they are reliable, and of course it takes load of our origin servers as well. So not every request is coming back to my website, and of course it helps my website performance for my local users. And what sits behind CloudFront? That's what we call the origin. So origin can be S3 bucket, it can be application load balancer, it can be EC2 instance where my website is running, it can be API gateway, or it can be a completely custom HTTP server as well. And all these different components which can be placed behind the CloudFront, which is ultimately served by the CloudFront, or are called origins. So origin is something from where the traffic is originating. You can understand from that perspective. And is a good thing, you can have multiple origins in a single CloudFront setup. So it's not like there is a one-to-one mapping. You may have static files from S3. You can maybe having APIs from application load balancer all through a single domain, which is connected to your CloudFront. So it makes it more usable in short, and you can have multiple scenarios, like if your website is served by different subdomains or your website is having different origins, all the origins can be served by a single CloudFront distribution. And that actually brings up to two key concepts we need to understand. One of them is distribution and another is behavior. Now, distribution is the top level CloudFront resource. When I create one, AWS gives me a domain like, I don't know, technocoffee.com, not like actually technocoffee.com. It should be like technocoffee.cloudfront.net, something like that, because that's a default domain which AWS is giving. And we can attach my own custom domain, our own custom domain on top of that. So technocoffee.com will come in picture now. Now, behaviors are where the routing will happen. So it let you map URL patterns to different origins with different caching rules per path. So for example, if I have slash API slash star goes to load balancer with no caching, and then we have slash static slash star in my website domain going to S3 bucket. They both are part of same distribution, same domain, but they have completely different behaviors. So that's the behavior part where we have different multiple sources sitting behind acting as an origin for my common CloudFront distribution. Now, few concepts we have to understand around CloudFront. One of them is cache keys. Cache keys determines whether a request is a cache hit or a cache miss. Cache hit is when some content which you are trying to access is actually found in the local cache, and cache miss is when the content is not found in the local caching, and then you have to access it from the main server. So by default, CloudFront cache is based on URL path, but we can extend the cache keys to include maybe query strings, headers, or even cookies. But there's a trade off. I mean, more things you add to the cache keys, the lower your cache hit ratio will be. And of course, more and more requests will be then not be able to find in the local cache, and you have to go back to the main server. So we have to make sort of some sort of customization in terms of making unique cache entries. Another concept is around time to live, which controls how long CloudFront holds a cached object. So your origins can also control this cache control behavior. CloudFront will let us decide or set minimum, default, or maximum time to live behaviors. Another important concept is around invalidation, which let us purge the cache content before the time to live expire. I'm not sure how important they are from the networking perspective, to be honest, but I think if you are designing your website and if you are building this infrastructure, these two components and these two settings must be really important. Now, as part of part two, let's discuss about some of the advanced design patterns of using CloudFront. One pattern could be having a static website and hosting on S3. And this static website, if you know about some sort of like website building on S3, so you can create your web server onto the S3 buckets. Your S3 bucket will be acting as a web server. And this is most common, I think, CloudFront behavior where you create your S3 bucket as a static website and put it behind the CloudFront. And you can, of course, use your origin access control policy so that S3 bucket is never publicly accessible and it can be only accessed via CloudFront. So that's one of the design pattern where you put CloudFront in front of your static website. Another pattern could be using API acceleration. So, where people actually want to access their application or their website, which is sitting behind an API gateway or a load balancer. And then you have CloudFront sitting in front of those services. So, in this case, because CloudFront gives you persistent access to your origin, you can route your traffic over AWS optimized backbone network. And you can, of course, get DDoS protection via AWS Shield as well, which is actually included as part of it, so which is kind of free. So that's the second scenario where you are putting your application load balancer or your API gateways behind the CloudFront. We can also put Lambda at edge and CloudFront function. This is where CloudFront is really powerful because you can run code at the edge as well, right in the request, and you can get response in that code's lifecycle, which is short-term lambdas. Another useful use case of CloudFront is using geo-restriction and geolocation routing. Now, CloudFront has built-in geo-restrictions to whitelist or blacklist entire countries. You have to use CloudFront functions to read the CloudFront viewer country header, and based on that header and route request, it's region specific to origins, and you can block from which country the request is originated. Now, imagine this one CloudFront distribution, one global domain, and then you have multiple users sitting in different regional locations and they are trying to access your infrastructure. It's really amazing solution to have content distribution locally on through the edge. CloudFront also provide a natural integration with the layered security. So we can have AWS WAF attached to the CloudFront. So we can put even CloudFront in front of our AWS WAF, which is Web Application Firewall, and then we can put origin behind the WAF. So that adds another layer of security in terms of how the request is passed from CloudFront to WAF. And after WAF is filtering that request, it will be going to your origin server. So that's another layer of defense in depth, which CloudFront provide as part of its built-in capability. Now, if I want to wrap up, CloudFront is not just a CDN, it's sort of your application's front door. And the core philosophy of the CloudFront is put more and more logic and traffic handling to the edge as possible. So no need to make your web server, your application which is running on maybe EC2 or your static website. No need to put more automation or more traffic rules handling logics on those location on the origin side. We can put or shift all these solution onto the CloudFront. It will help us in caching, authentication, routing, security, handle all the requests at the edge. So our origin actually stays pretty underutilized, and it's of course helping user getting fast and protected response from wherever they are in the world. So if you are hosting a simple static website, or you are even running a global multi-region API, I think CloudFront has different design patterns to support that. And that's why I think CloudFront itself is really important as part of understanding AWS advanced networking, because this is having multiple use cases which we can fit in and put in our different design scenarios. All right, that's it from today's episode. Now, in next week's episode, I will be covering 3 advanced design patterns for high available applications using CloudFront, and that will be going into more details and more technical. And I will be also covering AWS Global Accelerator basics as well, because that's one of the design pattern which we'll be discussing moving on as part of another subtopic. That's it for today's episode, and let's catch up in the next week episode and have more advanced topics on AWS networking. Goodbye and good luck.
Been listening to Cloud, Coffee and Certs. Thanks for tuning in. Don't forget to follow and share if you enjoyed this episode. Until next time, keep learning and keep growing.
If you're a podcast host, listen up, this one's for you. My name is Allie Jackson. I'm the host of Finding Mr. Height, a dating and relationship podcast that I've been doing for 4 years now, sharing my positive and practical approach to dating that's built on my own life experience. And I wanted to share another experience that I've had, my secret behind monetizing my show. It's called Red Circle, and I was just telling my colleague about how much I love their platform. With Red Circle, not only am I getting a seamless hosting experience, but I also love the support I receive in ad sales. It's not just typical ad sales either. It's targeted opportunities based on my show and my life. And the platform is super simple. You just set your preferences and Red Circle matches you with sponsors that align with your show. You can vet every opportunity and their platform gives you great analytics. More recently too, my Red Circle team has brought me opportunities outside of my podcast on social media to really augment the podcast partnerships, bring them full circle. I just can't recommend them enough. If you want to give it a try, go to redcircle.com to get your free trial. That's redcircle.com for a free trial.